And any other day, I really need you to come with a charged Chromebook and your charger. You're supposed to do that every day, but especially tomorrow because we are testing tomorrow. So number 9 on the first study guide, it says compare the rate of change and initial values. I can see why we might struggle with this one because it used different verbiage in the unit, but we still did compare those things. So like, what is another word for rate of change? Good, slope, and yes, slope is also rise over run. So maybe we didn't use the phrase rate of change all that much, but we definitely talked about slope. So you need to be able to compare slopes. And then when we talk about initial values, what are we talking about? What other graph feature did we look at a lot? Usually you plot it first. Y-intercept. Ladies, my microphone is really sensitive, so if you want your conversation blasted to the world, then something. But whenever we say initial values, we're talking about the y-intercept because usually that's your initial value in any real world. All right, but really mostly this section is comparing the slopes. It only has you filling in parts about the slopes, but just side note, your y-intercept is considered your initial value. And we have 2 different representations. I bet you are more familiar with the graph, so let's start with the graph. How do I find slope from a graph? Rise over run. So I'm going to count the rise over run between 2 points that I can see really easily. And when I say that, I mean like I wouldn't have to estimate those points. So like I wouldn't pick, I don't know, that point because I'd have to estimate it. And this graph actually has 2 points already identified, but normally you just pick 2 points that you can see really easily. Draw, or if it's on your computer screen, visualize a triangle. And you're counting your rise over your run to get from the left point to the right, like left to right, like how you lead. So what is my rise to go from this point to that point? 47. So my rise is the question. What is my rise to go from this point to that point? 4. Good. We're counting up 1, 2, 3, 4. If I was going down, that's when my rise would be negative, but it's not. We're going up in order to get from here to here. And now what's my run? 7. Good. So your run is always to the right. And you are counting like this is your 1. Your 0, 1, 2, 3, 4, 5, 6, 7. Put that together. That is my rate of change for function 2. Started with that one because that's more familiar. Slope is a fraction. It just needs to be a simplified fraction, and that one is simplified. Now for the table, those are all coordinates. We didn't do a whole lot with tables, but hopefully you know that tables of values are things that you can graph. So if I just take 2 coordinates from there, all you need are 2. It doesn't even matter which ones. But if I were to put them into Desmos, I feel like that might be easier for you because you wouldn't know the other way unless you remember from middle school. That also is funny. Here's one of the points. That's how you put it in with the parentheses, a comma. These are from the table. You only need 2. And then you're counting your rise over run to get to there. But look at what Desmos did automatically. How are these tick marks counting by? 2s. No. 0.5. So I probably wouldn't want to start counting these as like 1s or counting as 0.5s. So what I'll do is I'll zoom out to where now each tick mark is 1. So if you're doing it this way, make sure you pay attention to what the tick marks are. And you can adjust if you need to. So now from this point to that point, I need to count my rise. What is my rise? 4. Good. That's like from here to there. That's my rise. And what is my run?
7.
7 again. So they're equal. They have the same rate of change. But questions on that? Okay, so then when you are filling it out, they're both 4/7, and then the last one says, are they greater, less than, or equal to each other? They are equal to each other on the study guide, and put an equal sign. But also, like with tables, you can use Desmos. Desmos can graph for you, and you can count your rise over run. But with tables, I think this formula for slope is easier. And that's your change in y divided by change in x. That's just another way to say rise over run. So look at a pair of coordinates. What is my change in y going from 0 to 4? So then I would write 4. What's my change in x going from 2 to 9? So that's another way to see it. I didn't show you that in the unit, so that's why I should be done with right now. I just know how to do. But now if you want to use that formula whenever it's a table, that's change in y divided by change in x. Same as rise over run. Questions on that? Questions on others? Could be from any part of the study guide, could be from any study guide. Abram?
I can go from the
Yeah. What number?
4.
And how does it start?
It's like 19 over 10 x plus 8 over 5 equals 9.
Let's see. Let me pause this and then that's it. So the optional one is different practically every time you take it. So that's why that one's a really good indicator to see how you'll do on the test. But let me find it because there's a bunch of different number. So this one's on the optional one. Again, it's different every time you take it. So not all of you might see this one, but you need to be able to solve problems similar to it. And the tricky part with this one is that there's fractions. So what I would recommend you review is how can I make any fraction not a fraction anymore?
This one.
That wouldn't help necessarily for these. What does the fraction bar tell you to do? What's opposite of dividing? So if I want to make any fraction no longer a fraction, I could multiply by the denominator. So look at my denominators that I have here. I have 10, 5, and 5. I could do, I don't know, something once at a time, I guess, but to kind of make it more like one step rather than multiple, what I'm going to do is multiply the entire equation by 10. Because this is my biggest one, and also 5 is a factor of 10. So if I do that, then I can make every fraction no longer a fraction. I know it's like a weird concept to think about, but that's me. So if I multiply the first term by 10, it just becomes 19x, because what's something times 10 divided by 10? That same number. Okay, it cancels each other out. So that just becomes 19x. Over here, I'm doing 10 times 8 over 5. What's 10 times 8?
80.
What's 80 divided by 5?
50. Oh.
Okay, so then that's just going to be a 16. So it becomes plus 16. And then over here, I'm doing 10 times 9 over 5x. So what's 10 times 9? What's 90 divided by 5?
18.
Okay, I'll trust you because I was going to do it in my calculator, but my fingers are too big and it keeps messing it up. But anyway, this becomes 18x. So do we understand that?
Yes.
We saw in elimination how if you multiply a whole equation by a number, we're not changing the equation, we're just making it easier to solve. So if you have all these like different denominators, At least for this test, there's probably something you could multiply it by to make them all disappear at once. Okay, if you multiply by the denominator or a multiple of that denominator, you can make it no longer a fraction. And then this is easier to solve. So whenever you're solving equations, there's a few steps you typically follow aside from that, if that happens. But you distribute if necessary. Do I need to distribute in this one?
No.
So then you move on. Combine like terms if necessary. Do I need to in this one? No. We do need to move the variable to one side. And that's what we will do in this one, we have to. But that usually comes after distributing and combining like terms, as you move the variable to one side. Does it matter which one you move?
No.
It doesn't matter. Which one would you rather move, the 19x or the 18x? How do I cancel it out on this side then? Whatever you want. So then I get 16 equals, what's 18x minus 19x?
1x. Negative 1x.
Negative 1x. So the x is technically not isolated yet. Right now it's being multiplied by negative 1. What's opposite of doing that? Opposite of multiplying. So we're going to divide both sides by negative 1. And that makes our final answer
Negative 16.
Side note, if that's hard for you, but it's a multiple choice problem, we did this in a warm-up once where you could just plug in the numbers and see if it makes it true. And you could do that in a calculator as well. Whatever's easier for you, you need to solve regardless. Like you need to be able to know these steps. Typically, after you move the variable to one side, you have to isolate the variable, which could be like a 1 or 2 step equation. Ours was a 2-step, I think. Or no, it was just 1 step. But those are the steps for solving those hard equations. Questions on that one? Questions on others? Could be any study guide, even the paper one. Side note, if you did not get full points on the binder check, like it will affect you. You have 2 options. You could go back and take all those notes and show me your whole binder again. Or you could do those IXL skills that go in the project category, and that kind of cancels out some of those pages. And it helps you prepare for the test too. If you didn't get full points on that paper study guide or like the practice from yesterday, you can upload to Schoology anytime on those. Question? 7 on the study guide. Okay, hold on, sorry. The one that starts with Noah? You said yeah? Okay, what does it start with? Okay, so that's number 10. I guess. No, it's okay. Okay, so good question. This one tends to be hard for students, but it is, no one's asked it so far, so it's good to go over it. The equation below gives the perimeter of a rectangle. Which of the following is an equivalent equation? So notice in your answer options, what is isolated? So what we need to do is isolate W. The steps for doing that is the same as like any other solving. The only problem is that we're not going to get like W equals a certain number. We're going to get W equals an expression. It's more than one variable. So still the same premise as before when there were all numbers. If I want to isolate the W, I need to start with what is farthest from it. What's farthest from it?
2L.
How do I cancel out the 2L?
L.
Subtract 2L, because you basically want it to become 0 plus 2W, so to make that 0, you have to subtract 2L. Whatever you do on one side. So this cancels out on the right. I just have 2W. On the left are these like terms, P and L. So all I can do is rewrite them. And looking at my answer options, it looks like they have the P first, so that's how I'll keep it. If they didn't, then I would probably just rearrange the order like that, but it looks more like this in my answers. All right, now the W is not completely alone. What is opposite of multiplying to?
Dividing.
And whatever you do to one side. So it can be represented as W equals this, or if you remember that one warm up, it might be like this. Where like, if you do it to one term, you have to do it to both. And look what happens here. Technically, this would cancel to 1. But let's look at our answer options. Which one best matches what we have going on?
Let's say that P minus 2L over 2, the right answer.
Okay, good. Wait, did you say, yeah, this one. Not the one that's over 2L. We did not divide 2L and I can just divide. Or is it? Is it right? Yeah,
Yes.
it is. The other way to write it, that could also be right, is this way. But I don't see that option. So questions? All right, other questions from any study guide? We might have time for 1 or 2 more depending on how long. Dan? Sorry, one more time. Okay. Okay, so what is the rate of change for each function? So kind of similar to what we did before. What's another word for rate of change? Slope. So when it's an equation, let me zoom in a bit. When it's an equation, how do I know which one's my slope? The one in front of the x. So my rate of change is -5. Make sense? Good. So when it's in an equation, it's always in front of the x. When it's on a graph, how do I find my slope? So and it already identified 2 points that I can see pretty nicely. So I'll just use those. To go from here to here, what's my rise? Good. Rylan, stop. So that's 4. And what's my run? What's 4 divided by 2? Because it's rise over run. Good. All right, am I making sense so far or am I going too fast? Okay. So rise over run, do we understand that? Friend? Do we understand rise over run? Okay, so here's my rise 4. Here's my run 2. Put it together, rise over run. We can simplify that. 4 divided by 2 is 2. So for this one, my slope is 2. Okay, scrolling down. From a table, what's that equation I showed you today when it's from a table? You could do that. But I think this one's easier, but it's up to you. You could put it in Desmos and count your rise over run. I like change in y divided by change in x. So just pick 2 random parts. Change in y, how do I go from 0 to 3? And my change in x, how do I go from -6 to -5? So my slope is 3 over 1. Now it says function blank has a greater rate of change. So my table was 3. My function B was 2. My function A was -5. What's the greatest? Good. The 3 is the greatest, which was function C. Makes sense. All right, we might have time for 1 more. Any requests? Does everyone understand the paper study guide? I will post the answers to the paper study guide, so at least check your work later. Or if you didn't do it, see what your answers should resemble. No last request. Question 4. Okay, this one's kind of long, but let me remind you of the steps. Whenever you see it, you should do it first when solving for x. What is it?
Isolated.
No,
Oh.
that usually comes last. So first you distribute if necessary. Do I need to distribute in this one? Yeah, I actually have to distribute twice.
Can you stop?
All right, so when I distribute that 3, what do I get?
A 3x plus 6.
Okay, great. People always forget to multiply it by both terms. You have to do it by both terms. And also people always forget that you're supposed to keep the sign that's in front of each term. So when I distribute this, it's a negative 1/2. What's negative 1/2 times 4?
2. Negative 2.
Negative 2x. And what's negative 1/2 times 6?
Negative 3.
And you can use a calculator for that. I don't have time to show you, but hopefully you remember or ask me later. After distributing, what do you usually have to do? Combine like terms. So do I have like terms to combine?
Close.
So what can I combine? Anything with the 3x? And when I combine them, I get, no, I get a positive 1x. Can I combine anything with the 6? What can I combine? What is 6 plus negative 3? And it's positive, so I'll put 3, plus 3. If there's variables on both sides, then you move the variable to one side. I don't have that in this one. And then lastly is when you isolate x. So like the 1 times x is just x. I'm gonna erase that. What's opposite of adding 3? And that's what you do to isolate x. Use your inverse operations. What's 34 minus 3? So that's your answer. Follow these steps anytime it's a multi-step equation. The first 3 are if necessary. You won't always distribute, won't always combine like terms, but if you can, you can do both. All right, well, test tomorrow. Get a good night's sleep. Do your study guides.
I'm gonna 0.